Physics Bites,
a science podcast in English
by the students of Notre Dame d'Ascension.
Hello and welcome to a new episode of Physics Bites, the English language physics podcast of the students of Notre Dame d'Ascension here in Paris. We are here with a new episode of our carbon emission series with the junior level students. This time the theme is going to be buildings. Buildings are going to be one of the key things that we're going to have to think about if we're going to deal with our carbon emissions, especially with the whole work of modernization, especially here in Europe. We have 4 new students. They're going to present themselves. I'm going to get right into the thick of things. So, how about you guys introduce yourselves?
So my name is Rayan.
We have Rayan.
Hello, my name is Rose.
Rose.
Hello, my name is Luca.
We have Luca. And,
Hello, my name is Noé.
and Noé, who you may have heard before as he was the co-host for another episode previously. So, let's get right into the thick of things. Give us a short summary of what you found out about when you looked into the whole carbon footprint of our buildings, the way you guys decided to spread out the work, and then we'll get into how we can fix this big problem. So, Noé, I think you're going to start?
Yes. Our buildings are a central part of our daily lives, and we spend a large part of our days in them, at home, at work, or during our spare time. The built environment is, however, the single largest energy consumer in the European Union, and one of the largest carbon dioxide emitters, as its total consumed energy accounts for over 1/3 of the global consumption and emissions. During our presentation, we learned about the causes of its emissions, but most importantly, how to solve those issues. So, what are the causes? Obviously, we could point out a ton of inefficiencies in the building sector. Nevertheless, the main ones and most relevant would be the HVAC systems, building envelopes, and construction materials.
Okay, so you're talking about, on the one hand, the way we cool and we heat our buildings, and on the other hand, the way we isolate them, I guess, thermically, right?
Yeah.
Okay. So, what did you guys find? Rose?
I'm going to talk about the HVAC systems and also the building envelopes, because it's one of the most important points of the building sector, especially when we talk about carbon emissions, because HVAC systems account for around...
Let's get started. HVAC. That's an acronym.
yeah.
Which stands for what? HVAC.
Stands for heating, ventilation, and air conditioning systems. So basically what heats and cools your apartment, for example. So those systems account for around 40% of a commercial building energy consumption, but also the same for residential buildings.
So let's just be clear, you are making a separation between what we call residential and commercial buildings because they don't have the same criteria.
Basically, a residential building is like your apartment, so where you live, its goal is a habitat, so bedrooms, kitchens, etc.
Living room.
Yeah. While commercial buildings are more for everything that's related to business, work,
Shopping, I guess.
Yes.
So it could be stores, it could be businesses, yeah.
Facilities, public facilities.
And they don't work in the same number of hours, commercial buildings are never being used at night.
They have different needs, obviously.
Right, and don't have the same sort of a density of people in them and all this. So we're making that separation. All right.
Yeah. So HVAC systems are crucial, and their role is going to be more and more needed because of the temperatures rising. So people are going to need more heating or more cooling, and it's very expensive in terms of carbon emissions because there are many inefficiencies that we find in those systems, such as the size of the HVAC system, which usually...
So just so we're clear, what do you mean by inefficiencies? What do we call an inefficiency when it comes to such a thing?
Usually, when you have an inefficiency, you're going to have a lot of waste.
Right. So energy that's being spent, but not producing the desired effect.
It's not very adapted to your environment, the HVAC system.
Okay.
So you'll have the size, because sometimes your HVAC system is going to be too large or too small for your building requirements, which can lead to an excessive energy consumption, for example. You're also going to have the maintenance, because you'll have dust that will be blocked in the conducts, etc. So your hair will not be able to go through easily, and therefore it will also require more energy. And also the poor insulation, because it will depend too much on the weather outside if you need to cool or heat too much. And so to solve those inefficiencies, we find many points, such as the use of to adapt that good insulation, good materials,
Right.
To improve the insulation, to also improve the sizing. You have the idea of smart thermostats, which can be used, which I'll also talk about later, I think, and also zoning to adapt more to the temperature of your building.
Okay. And what I think Noah mentioned it in the beginning. This is a particular problem for us in Europe, given that most of our buildings are pretty old, and so the materials used is not necessarily as adapted to our insulation needs as it would be in more modern buildings, which you have maybe in some other parts of the world. Okay.
That's also the problem with those old buildings. The building envelope is also not adapted, not as in the new buildings now.
So let's, before we go into some of the details of this, do you guys have some numbers in general, like what percentage of the world carbon emissions are due to our building inefficiencies and things like this, Luca? Just so we can get a global picture, and then we'll go into the details.
For example, if you to make it very clear, if the cement industry were a country, it will be the third largest emitter of carbon dioxide in the world, at up to 2.5 billion tons, surpassed only by China and the United States.
Okay, so why are you mentioning concrete as we're talking about buildings?
Yeah, because there are many materials used in the building industry for constructing a building. However, the most used today in the world is concrete.
Right.
And it's a mixture with cement, water, and gravel.
Right.
And it's nevertheless very polluting.
Okay, so one of the things, so we've talked about several things. Let's try and organize things. You mentioned, for example, the way we lose heat in buildings. You're mentioning the way the system we use to heat or to cool the buildings are inefficient. So a lot of the energy that's being used is not actually being used to heat or to cool. It's being lost. Now you're talking also about the emissions due to just the materials that we're using for buildings. Let's go in order. Maybe we can start with the building materials.
Yeah, of course.
And then we come back to, once we've built the buildings, how we can get things better. Okay. So talk to us about cement.
So cement, as I said, is a mixture of cement, water, and gravel.
Concrete, sorry.
Concrete, yeah. And we know that the carbon footprint of the water, sand, and gravel contained in concrete is particularly low, unlike that of cement. In fact, cement only represents 11.7% of the weight of common concrete, but it is responsible for 98% of the GHG emissions of the concrete
greenhouse
materials.
gas emissions. Right.
Exactly. Sorry. For two reasons. Its manufacturing process is very energy intensive.
Okay, what do you mean by it's very energy intensive? What does that mean for us?
It means that it consumes a very large amount of energy.
Right. And why is this? Why is cement so energy intensive?
Because there is a material in the cement that needs to be heated at a very high temperature.
Okay.
And via fossil fuels.
Right. So in a way, the reason that cement currently is very energy intensive and very carbon intensive is because it needs to be heated, and most of this heat comes from burning fossil fuels.
Exactly.
Where is most of the cement in the world made?
That's a good question. I don't have that.
If I'm not mistaken, I think there's a lot of it made in China, right? Because it's one of the countries which has the most building projects and also has one of the more.
Exactly.
And if they had more carbon, let's say, free sources of energy, then maybe the cement production would be much less carbon, have much of a less of a carbon footprint. Okay, go on.
And the second reason is the decarbonization of limestone, which is a chemical reaction producing CO2. that is responsible for the remaining 2/3 of cement's GHG emissions.
So that also requires heating?
Yeah,
So
exactly.
it requires heating, which produces carbon, and it releases carbon dioxide, which
exactly,
increases the carbon footprint.
exactly.
Okay, so it's double bad.
Yeah. During the manufacture of cement, it is the manufacture of clinker which will generate the most GHGs.
Okay.
So what is clinker? Clinker is the main component of cement, obtained by cooking limestone and clay, 80% of limestone and 20% of clay. When the raw material is heated during the clinkerization phase, decarbonization of the limestone will take place. So this decarbonization
Yeah.
from limestone occurs from 650 degrees when a certain gas emits a molecule of carbon dioxide from a quagmire. So quagmire will make it possible to make clinker and then cement, while carbon dioxide is a waste product of this reaction.
Okay, so we're heating to very high temperatures,
Yes.
close to 700 degrees,
Exactly.
which is burning up usually a lot of fossil fuels to reach that temperature.
Yeah.
And we're also releasing large quantities of carbon dioxide because we're producing a lot of cement. Okay. Maybe we can quickly go into some of the questions around, is it possible to create cement in a more clean way? Is there like any such thing as clean cement or green cement?
Yeah. So today we have a material that exists, and it's the low carbon concrete.
Okay.
So we had the question: what is the difference between normal concrete and low carbon concrete?
Mm-hmm.
And to make it quick, low carbon concrete consists of industrial cement combined with mineral compounds such as calcined clays, fly ash, or blast furnace slag. It's
very technical.
Yeah, very technical.
Okay.
But depending on the dosage of these additions, the carbon footprint of concrete can be reduced by up to nearly 70%.
Okay, that's a huge improvement. Why are we not doing this everywhere?
Because these materials are very we cannot find them everywhere.
Okay.
And the way of doing the low carbon concrete is very complicated and long. Okay. And to make concrete is very easy.
Right.
You can make it everywhere.
So we can do clean concrete. It's just that it's not very convenient.
Yeah.
So
it's more
expensive.
Expensive, so
right, because there's it's more difficult to procure these substances, and it takes longer, which means that economically, it's not very viable.
Exactly.
Are there any other ways of producing clean?
But there are many other materials today that can be used to the building to construct a building. So, for example, there is wood.
Yeah.
That is a more natural compound.
Which is already used in a lot of maybe countries like Canada, Sweden, Nordic countries.
Northern countries, exactly. Yeah. And it is on this way to be democratized in our countries. So,
I guess the problem with that would be we can't really build very big high rises with wood. That's more right, and the lifetime is shorter. So it depends, I guess, on the kind of architecture we also want to do.
Yeah.
Okay.
But there are many solutions. One of them is the installation of prefabricated elements to create from scratch an extension or even a building. This is called modular construction, and it's been used for the past decades. But in these decades, there are lots of buildings like that now. And in the prefabricated elements, the structure avoids unnecessary connections and places part of the building in one block. These structures can be built from wood for lower carbon footprints, and in this construction method, the elements of a building are designed and manufactured in a workshop or factory, transported and then quickly assembled on the site. So it's inexpensive, quick, and ecological.
Mm-hmm. And modular buildings.
Yeah.
Are we using this in our current societies? Like, are we building houses modularly, or is it something that's modern and more like very niche? Is it only certain countries, certain people are doing this, or?
Yeah, of course, it's not democratized today, but
why is that? Is it costly, or is it just requires
it's inexpensive, quick, and it's
You have
a
to have
really
the
good method.
facilities to actually build these.
Sorry?
You need to have the facilities and you need
Yeah,
to have
exactly.
the factories
But-
to build these sort of.
But in a certain way, it could be the future of the building construction. But the problem is that wood is not a material very used in the building construction because of the disadvantage of the wood.
Which is the duration and
the duration,
that,
the life, duration, and other things.
the fact that you can't build like very huge, big structures.
Exactly, and there are a lot of rules
Yeah.
today in our country regarding of the wood construction.
Right. For the protection of forests and the sources of wood.
Exactly.
Okay.
And also for the security of the buildings, because it cannot support a large amount of device and and
like the weight that it can support
exactly.
is not very, very high. Maybe we can come back to that later.
Yeah,
okay.
yeah, later,
So let's move on to some other stuff. Maybe we can move on to talk to Rayan, who was working on which aspect did you work on in your topic?
On the lighting of the building.
Okay, so lighting, which we're talking about the electrical infrastructure of the building. Okay, so let's hear what you found.
So I will more precisely talk about the efficiencies of the lighting and equipment, like Rose did for the HVAC systems. So the lighting sector accounts for a significant portion of the demand of energy in buildings.
Okay.
So in 2022, the electricity demand for lighting slightly increased, causing a slight increase in CO2 due to the lockdown and the coronavirus.
Right.
Household and appliance.
What you're saying, because we're spending more time in our houses,
Exactly.
we spent more energy, and so we produce more carbon because of lighting.
Also about the appliance like refrigerators, washing machine, and television that we use, as you told, way more than usually. So despite efficiency improvement in devices, the demand of energy in lighting is still very important. In 2022, so due also to the ownership and the usage, so there were improvements in the carbon intensity of electricity, but still there's a lot of work to do.
So give us the main ideas behind how we can reduce the carbon emissions from our buildings through improvements in our lighting policies or lighting techniques. So just like the very basic ideas.
I will talk. I can talk right now, but for the lighting, basically we can use LEDs.
So that has been a huge change for everybody since we moved on to LEDs. We have been using the same amount of, like, much less electricity to produce the same amount of light, which has really reduced by close to 60-70%, I think, our electrical consumption.
I've been asked why are LEDs so much preferred. So there's many aspects that lead us to the using of LEDs in our everyday. So LEDs are highly preferred for several reasons. So as evidenced by the trend of the lighting sector, firstly, the LEDs are significantly more energy efficient compared to traditional bulbs. This increased efficiencies leads to a lower electricity consumption for lighting purposes, which aligns with the global efforts to reduce energy demand and mitigate the climate change. So I will talk why are LED more energy efficient. So LED convert more energy than being consumed into light rather than heat.
Right, because the old style lighting that we had was producing light from heat, and here we're producing light without producing heat. So in a way, we're being much more efficient in terms of how much of the electricity we use is doing what we want it to do.
Exactly. So in contrast, traditional fluorescent bulbs work by heating a filament until it becomes that hot that it will become light. But LEDs don't work this way. So it directly converts electrical energy into light energy with a minimal heat production. I will also LEDs have a longer lifespan than traditional
light bulbs.
Yeah, exactly. So that reduces the frequency of replacement and also the carbon emission. Moreover, LEDs offer a better control over the light, as we can see with the smart lamps with our phone. We can visually control how it emits light, the color and the intensity.
Right. So I'm going to cut you off just so we can save on time. At one point, Rose mentioned the idea of smart thermostats for controlling, for example, the way we control the temperature. And you, in your presentation, you talked about BMS, Building Management System, which is like treating the building as like having a sort of central nervous system. Can you talk very quickly about what the idea there is?
So there's a lot of type of BMS. We can consider the automatic light as a BMS.
Right, like the ones that detect movement, and when somebody's there, they light up. Okay, like a very basic kind.
Exactly. Yeah.
Okay.
So there's a few types, as I said. The real-time monitoring and control BMS. So they control continuously the energy usage, temperature, and humidity. So that link with the HVAC system that Rose talked about. BMS can identify efficiency in lighting and HVAC systems. So it can predict when a device can break, so we can replace it before it
actually. So you're talking more about, for example, using something like artificial intelligence now to sort of try and understand and predict the behavior of people using a building in order to make things really much more efficient, right?
Well, actually, the artificial intelligence made a big step for BMS.
Do you have any examples of this that we have used, for example, or at least the cases that are going to be used?
Well, there's one type that will be very popular in the years going. So it's the BMS that will help building use renewable energy. So it will integrate wind turbine, solar panel, and the BMS will manage to organize the building so it use mostly this renewable energy.
Okay. I guess it's much more futuristic in the sense that we have to have already much more of a infrastructure for these kinds of renewable energies before we can actually sort of make our own mix that works well. So, Noé, do you want to talk to us a little bit about the aspect of the presentation that you worked on when it comes to buildings?
Okay, so I'm going to talk about the life cycle of the building. So there are 4 parts during the life cycle of a building. There is the produce,
right?
The construction, the use, and the end of service.
Right.
So the construction and the end of service produces 60% of the carbon emissions produced by the buildings. And so one of the biggest change that we could do in the end of service is that instead of only demolish the buildings, we can reuse it.
So let's be clear. When you talk about the end of use, what do we mean concretely? What is the end of use for a building usually today?
When there aren't any more owners of the houses and we have to demolish it.
So that's what we do pretty much all the time, right? So we take a building that's not in use, let's say it's an old house and we want to build a bigger building on that space, we destroy the house and we build on that land.
Yes.
And you're saying that there's another way of doing this without necessarily destroying, which would be much more energy efficient because that's where all the energy is lost in the carbon emissions. Okay.
So we could reuse some parts of the houses to add to some other houses that are partially constructed. Like all the cooling system of a house could be transported to another house and it would gain less carbon emission would be produced.
Right. If most of the carbon emission comes from the production and destruction, then if we're not actually reproducing something from scratch, then we're going to use, it's kind of like recycling with materials, right? It's the same idea. That. Okay. Did you also find anything about actually recycling building materials or not? As opposed to like when we destroy it, we sort of just throw it away, right? This mostly concrete and wood and everything. Is there any way of recovering that stuff?
Yes, we can reuse some parts of the materials used for the construction of our first house. So we will demolish it.
Okay.
And we will reuse like some parts of the concrete or cement to build another house or another building. And it would be very more efficient in terms of carbon emission.
Okay. So if I can come back to Rose, maybe. You mentioned like heating and cooling, HVAC systems, but you also mentioned insulation. And I know that insulation is a big question for us here in France. The government wants they want to subsidize a lot of that. Can you talk to us about some of the technology that might be coming, it would be really useful for talking about like a good way of insulating a house? Because if we do insulate well, not only is it good for the winter, it's also good for the summer, right? In the summer, we can keep it cold with very little energy spent. In the winter, we can heat it up with very little energy spent. So it could be actually a big game changer. So do you want to maybe talk to us?
Yeah. So what's used for insulation is the building envelopes, and its service demand has increased by now 2/3 since 2010. So it's crucial now in 2024 that we need to find the most efficient way and the less expensive, ideally, way to insulate our buildings for heating, cooling, and also to guarantee your comfort in your apartment, for example.
Okay.
And so one of the main ideas that emerged is the use of silicone aerogel.
Silicone aerogels, which is this very special materials which has some weird properties.
It's a porous structure. It kind of feels like polystyrene when you touch it. It's very light. However, it's very, very insulating since we use it, for example, for the Mars robots and stuff. So used for space.
Yeah.
And so
it is, I think, if I'm not mistaken, the least dense materials
Yeah.
that we have. So it's
because
almost
of
wasteful.
the very porous structure. I think it's almost 98 or 99% composed of air.
Right.
And
And that is the reason why it's also very insulating, right? Because it's porous structure. It's like a double
There's
layered
no way
windows.
to conduct any heat.
That's exactly it. So how would we use aerogel as a way of insulating our buildings? Is it just like put it everywhere?
No, it's inside the walls. Basically, you just put it
Like a layer,
between.
right?
Kind of. Exactly, and it just works efficiently.
Be advantageous because it uses much less materials. How easy is it to fabricate?
So less space.
It takes much less space.
Yeah.
Right? Is it easy to make? Is it costly? Is it readily available?
It's synthetic, so we can make it as much as we
Are we using it for insulation in buildings currently, or not really? No.
I don't think so. But if we do very, very few, because it was basically used for space and experimentations and stuff.
I think with its production in mass, maybe it's going to become easier to use. And would it make a huge difference?
Actually, in terms of cost, energy loss, space.
Okay. It's like a miracle solution, right?
Yeah, kind of.
Okay. What other? You talked about passive radiation cooling. What is that?
Yeah. So it's a specific type of material, and so basically when the sun is on a material, it's very
It's like shining on.
it absorbs the radiations and it heats up.
Yeah.
And if we use those smart materials, we call them super cold materials. It will not absorb but reflect, to put it in space, and so it will not heat up, but just stay at basic temperature, and so the building would not heat up, and you won't have to cool your.
I guess this is something that would be useful in places which are very
warm, usually.
warm and light intensive, so you don't have to actually spend
But it's
energy.
mostly where the need of good cooling systems are required the most.
Okay, so that's much more geographically specific.
Yeah.
What are these? What are the advantages of smart thermostats that you mentioned also earlier on? Why is that a desired solution? How can that be a good solution?
So basically, smart thermostats is a way to adapt mostly your HVAC system to your building, because it will predict your needs in terms of heat or cool.
Yeah.
And so we will save energy. It will save electricity, and therefore it's beneficial for both the homeowners, since it can reduce the bills, for example, of the light, but also for the environment. So it's totally beneficial. However, there are also some negative points, because the installation can be very complex, and it requires some technical knowledge, kind of. So
have sensors everywhere, and you need to.
Yeah, exactly, and it also depends on your data.
Right.
So it uses internet constantly, and it can be uncomfortable for
the
people.
use of internet. It could be, on the one hand, it is kind of having its own carbon footprint, and secondly, for now, it's going to go by
so I think
some sort of
it's a bit too new, and we need to maybe look more into the topic, because indeed there are some good points about it, but also some significant negative points.
Okay, so it is something to be thought of, but it still hasn't been really optimized. Okay, well, maybe we're nearing the end. Maybe we can talk very quickly about so Luca, I think you spoke to us also of heat pumps, and that's a very big topic, because there's a lot of government effort to try and motivate people to install heat pumps. Can you just maybe very briefly go over what the advantages of something like that would be?
So heat pumps are heating equipment using the energy naturally present in our environment, thanks to a refrigerant which easily absorbs heat. This fluid circulates in a pipe to a compressor which will increase its temperature. This heat is used for heating and the production of domestic hot water. There are different types of heat pump: air-water, or water-water heat pumps. The first term designates the energy source of the heat pump, and the second the way in which the heat is rebroadcast.
Okay, so if we just try and really boil it down, the idea of a heat pump is, instead of producing heat by burning something, so taking heat, like creating heat, we're just transferring heat.
Exactly.
And mostly we're transferring heat either from the ground, and it can also be used to cool in the summer, where we're transferring the heat from the house to the outside, which is kind of what a refrigerator does, which is kind of what an air conditioner does. And the advantage is that, first of all, because we're not burning anything, we're creating less carbon. And secondly, it uses less energy to make this transfer rather than just to create the heat from burning. Okay, so we've gone through the technical solutions, which are very important, and like the building solutions and stuff. Maybe the final point, we can talk about what sort of a role regulations and government and policies might have on this. So maybe quickly we can go over that, and we'll finish up on that.
So I can talk to you about the most recent regulations in France. So improving the energy performance of a building has always been at the heart of thermal regulation. And the most recent regulation is the RE 2020, and is not an exception to the rule, and makes limiting energy consumption one of its priorities. It therefore covered most of the basis of the RT 2012, that was another regulation in terms of energy.
Let's get just really to the basics of what the regulation is trying to do. What are they trying to
energy
regulate?
performance therefore aims to reinforce energy sobriety, favor less carbon-intensive energies, and move away from fossil fuels, and systematize renewable heats. And finally, there are 3 indicators that reflect the energy performance of buildings.
Right, that we've seen a lot of.
The BBO indicator, so a bioclimatic need of the building, measured in points. It characterizes the energy efficiency of a building by measuring the energy needs for heating, cooling, and lighting. The CEP indicator, primary energy consumption. It evaluates the consumption of renewable energy for different use, and the CEP-NR indicator, it evaluates the consumption of non-renewable energy for different uses. So the environmental performance is at the heart of the new 2020 environmental regulations. Indeed, it highlights the decarbonizations of buildings over an entire life cycle that Noé talks about, and that is to say that putting in place measures and techniques to reduce greenhouse gas emissions, and most particularly CO2.
Okay, so I think we can keep on talking about this because it is a very interesting topic, but let's finish up on just maybe you guys can tell us what you found interesting in your research, because you guys did a lot of research and you found a lot of things. I learned a lot of things working on this with you guys, or at least listening to you guys talk about it. What did you guys find most interesting during your research? What did you find most striking about this, and how is there anything in here that has convinced you to change your behavior in some ways? Or
well, I think the most interesting thing I found is definitely silica aerogel, because it's so interesting to see that a material that we basically used for space and stuff can be used in our
Yep.
daily lives around us. I feel like it's kind of weird, but also very interesting. And
It's
now
also
that
another reason why we should do fundamental research, which has no applications, because somebody will find an application later,
yeah,
maybe not right away.
yeah, but I love to learn about how it was used and
Mhm.
how it was made and stuff. It's pretty interesting.
Okay. Any of the other guys, maybe quickly,
Yeah.
because the bell is going to ring, Ryan?
For my part, about the LEDs, I didn't know how much of a changement it
Yep.
was compared to the traditional natural light. So yeah, as I already made my research, we can talk about evolution in the
Yep.
lightning.
Yeah, that's a very good word for using, because it has completely changed the amount of energy we use from this, whereas before we were like, oh, turn off the light when you go out. We should still do it, but if you don't do it, the difference is almost minimal because of the fact that we've changed the way the lighting has, the technique has changed. I don't know, Luca, you have a particular maybe interest in this because you have people in the family. Your father was an architect, you mentioned.
Exactly. And it's him who showed me some pictures of his
Right.
work, and I learned about modular construction by him.
Right.
And I think it's maybe not impressive when I talk about it, but I encourage you to search some pictures of it on
Yep.
the internet, because it's very impressive when you see it with your eyes, and you see it is big,
Prefabricated
you get,
modules coming in
yeah,
together,
and,
making
that can be really a room, an entire room made by only one piece of wood.
right.
So it's impressive, and I encourage you to. Search.
All right. So thank you very much for your presentation. It was very, very interesting. We learned a lot of stuff, and we hope to see you next time.
Thank you.
Thank you.
Thank you.
So that is Physics Bites for this week. We do hope that you enjoyed this episode. We certainly did. But before we say goodbye, it's that time of the episode. Your turn to think about the following question. What is, in your opinion, the best way, the most efficient way we could increase the efficiency of our buildings and reduce their carbon footprint? Is it through more intelligent control of the temperature? Is it through better materials? Is it maybe living underground? What is your opinion? Leave a comment and let us know. And so, once again, thank you for listening to Physics Bites. We hope you enjoyed the episode, and we hope that you'll be back next week for the next episode in our carbon emissions series.